Good morning, Cappuccino. It is Wednesday, April 15th. Here is our warm-up for today. I want to do a review of logarithms. So go back into your notes and see what the rules are, or you can look at your formula packet. There's some hints for how to do these in the formula packet. These two are pretty straightforward. These two are pretty tricky, but I bet you can figure them out. So, and then you're going to be solving for x on these. Again, this one's pretty straightforward. This one's a little bit trickier, but not much. Okay, so I think the hardest problems on here are C and D, so those might take a little bit of brain power. All right, so let's go over yesterday's warm-up. And again, extra credit for the first 6 people who gave me that. Yesterday's warm-up, I wanted you to find the integral and evaluate it from 1 to 6 of 12 over x dx. And do it without a calculator and do it with a calculator. Okay, so without a calculator, I notice I've got this 12 here, so I can rewrite. Let's see, do I want scratch paper for this? Now let's just try and do it on here. So I'm going to rewrite this as 1 to 6 as 12 times 1 over x. Okay, that's the same as 12 over x. And then, of course, dx. Whenever I have a constant, I can bring that out in front. So 12, 1 to 6 of 1 over x dx. And then if I check my formula packet, do I know how to integrate that? Yes, we know how to integrate that. We integrate that by changing it to natural log. So this is going to be 12 times the natural log of x evaluated from 1 to 6. So now I need to substitute in my 6 and my 1 and subtract them. So I'm going to have 12 times natural log of 6 minus the natural log of 1. And I had a lot of people distribute the 12 and then leave it like that. But this could actually be simplified. Natural log of 6 minus natural log of 1. Using our rules of logarithms, we can, when we have subtraction, we can put these together as long as they have the same base. It means that we can change this to 6 divided by 1. So this is the same as 12 times natural log of 6 divided by 1. And 6 divided by 1 is just 6. So the final answer here is 12 times natural log of 6. That's the final answer. All right. You also could have evaluated this all by itself. So if I have, where am I going to put this? I'll put it up here. If I have natural log of 1 is equal to something, let's call that something x. I don't know what it is. I can rewrite this in exponential form. So I know my base here is e. So e to the what is equal to 1. Well, to get a 1, the only way to get that is to raise something to a 0. So therefore, x is equal to 0. So this right here, natural log of 1 is just 0. Okay, so that's an even faster way of getting to your answer, because natural log of 6 minus 0 is just natural log of 6, so you're just left with 12 natural log of 6. All right, so that is the simplified version. Some people wrote plus c at the end. No plus c. We only do the plus c when it's an indefinite integral, when you don't have boundaries to evaluate it at. Okay, so this one does have boundaries that we're evaluating at, so no plus c on that. This is the answer. All right, so if we do this on the calculator, let me get my calculator ready to go. What's going on? Okay, here's my calculator. I'm going to enter in my graph, which is 12 divided by x. Okay, I'm going to enter that in, see what it looks like. Okay, there it is. And then I'm going to ask to integrate it. Second, calculate. Option 7. My lower limit is 1. My upper limit is 6. And it tells me my area is 21.5. 21.5. So this would be 21.5. And that would be, well, we're just integrating. We're not asking for the area, right? So we'll just put 21.5. All right, so there that was on the calculator. Now, we can check and make sure that this answer matches this. So I'm going to get out of my graphing mode, and I'm just going to do 12 times natural log of 6. See what it gives me. Oh, same answer. Ding, 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 bingo. Got it right. All right. Next one, sketch y equals sine of 2x. And I didn't say you couldn't use a calculator, but if you're going to sketch it, you got to put some numbers on the sketch. Okay, so if I go ahead and put it into my graphing calculator, sine, where's sine? There it is, sine 2x, and I graph it. And notice I want to go from 0 to pi. So you can see in my window, I'm already have my y-axis is over here, so I'm already starting at 0. But how can I get it to go to pi so I know how wide this thing is? Okay, so I'm going to switch my window. So for my x, my minimum is at 0. I'm going to make my maximum be pi. So I'm going to clear out what I had in there, and I'm going to put in pi. And let's go ahead and see what it looks like. Well, lo and behold, what do you know? It completes one cycle by the time it gets back to pi. So if you remember your transformations and you remember your basic sine function, so in our basic sine function, the amplitude is 1, the period is 2 pi, and so if I was just doing y equals sine of x, I would start at 0, and I would go up to 1 and down to -1. So it would go up to 1, down to -1, and back up to where it started, and it would get back to where it started by 2 pi. Well, this is my horizontal shift in here. This is a horizontal transformation, I should say, not shift. This is a stretch or a shrink. Since it's in backwards land, it's in here. Since it's in backwards land, it's not making it twice as wide, it's making it half as wide. So if normally it's 2 pi wide, it's only going to be pi wide. So I am going to put this as pi over 2 and this as pi, and I'm going to complete my cycle by the time I get to pi. And I'm going to call this 1, and I'll call this -1. Sine starts at 0, it goes up, comes down, goes up, down. So here is my sketch. Okay, so notice how I labeled my x and my y axes. That is important. Okay, we need to know that you understand what the amplitude is and what the period is. So the period is pi. It makes one complete cycle in between 0 and pi. All right, now I want to find the area, and it's okay to use the calculator on this. So back to my calculator. I want to find the area between 0 and 0.5 for the first one. So if I do second calculate, I want to get my, actually, you know what? I want to go to window first. That was bothering me. I want to go -2 and +2. I want it to look more like my sketch. Ah, that looks nicer. Okay. And you notice the tick marks? The tick marks are not in increments of pi, so I'm going to fix that also. So you see how it says x scale is 1? I'm going to make the x scale be pi divided by 4. Let's cut pi into 4 pieces. Now this will look super good. Oh yeah, that looks much better. Okay, so now I'm going to go ahead and find my areas. So if I do second calculate, number 7, I'm going between my lower is 0 and my upper is 0.5. Hit enter, and it shows me the area right there, and I get an answer of, where are my glasses? I can't see that. 0.230 if I round that off correctly. So this would be equal to 0.230 units squared. That would be the first one. And then the next one, option 7 again, I'm going between 2 and 3. 2 and 3. Okay, there it is. Now notice it gives me a negative answer. Oh, but area can't be negative. It's negative because it's below the x-axis. But when I write my answer, I want to write it as a positive. So that would be negative. Sorry, I just said write it as positive, and then I wrote a negative. So it would just be positive 0.807, again, units squared. And then the last one, if I put that one in, on option 7, I'm going from 0 up to 2.5. It filled in a whole bunch. Unfortunately, I don't know how to get rid of the old shading that's in there. But I did notice as it was filling in, some of the area was above and some of the area was below. And it gave me a total area of 0.358, which doesn't seem to make sense because it was all of this plus some more of this. So that seems like it should be bigger than either one of these, and right now it's in between them. And that's because part of the area is below the x-axis. So I could break it up into two pieces and just find, figure out what this is, which I actually know is pi over 2, and I could find that area, and then I could find the area on this side of pi over 2 and take its absolute value and add those together, but that's way too much work. There's an actually easier way to do this. So I'm going to go back to my graphing. What I want to do is take the absolute value of this sine function. I want the entire curve to be above the x-axis. So the way we do this is we're going to hit Math and then Number, and the first option is absolute value. Okay, so let me do that again. I did that kind of fast. So I'm going to put in a new function here. So I'm going to y2. I'm going to hit Math and Number, so scrolling over to Number, and option 1 is absolute value. I'm going to select that. Notice it gives me the absolute value lines. And then I'm going to type in sine of 2x. Okay, now I'm going to graph that, and you'll see the difference. It's in red. See what happens here? Instead of going negative, it stays above. Same curve, but it stays above the x-axis. Okay, I'm going to hide the first graph, so we just see my absolute value one. And now I'm going to ask it to find me the area underneath the curve on part C. So second, calculate option 7. I'm going from 0, what was it, to 2.5. And notice all of that area. Now here's the part that would have been negative before. Now it's positive, and see the difference? My area is 1.64. Okay, so, oops, not 0, sorry, 1.64. Haven't had my cup of coffee yet. 1.64 units squared. All right, so that's a really nice feature on our graphing calculator, so that you don't have to get all fancy and figure out where is the line crossing the x-axis. You have to do that if you're doing it by hand, but if you're doing it with a calculator, you can just use that Math, Number, absolute value, put in the absolute value, and that'll flip the parts of the curve that were below the x-axis. It'll flip it above the x-axis, and then you don't have to worry about part of your area being negative. All right, so that's if you're finding areas. Okay, so today you will find there is going to be a math space assignment, but there's some notes that go with it. So the assignment, oh, I forgot, I wanted to talk about yesterday's. So yesterday's assignment, I'm going to talk about in my next video, okay? And then I'm going to tell you what's happening with today's assignment. So you're going to be practicing more with a trapezoidal rule. So I'm going to go over that in the next video. So anyway, this was the warm-up. On to the next video.